Introduction to static electricity. Static electricity is the buildup of electric charge on the surface of objects. Unlike current electricity, which flows through a conductor, static electricity remains stationary until it is discharged. This phenomenon occurs when there is an imbalance of positive and negative charges on an object's surface. How static electricity builds up. Static electricity often builds up through the process of friction. When two materials come into contact and then separate, electrons can be transferred from one material to another. This transfer causes one object to become positively charged, losing electrons, and the other to become negatively charged, gaining electrons. Common examples include rubbing a balloon on your hair or shuffling your feet across a carpet. The role of conductors and insulators. Conductors, such as metals, allow electric charges to flow freely. In contrast, insulators, such as rubber or plastic, do not allow charges to move easily. When static electricity builds up on an insulator, it stays on the surface until it can be discharged. Conductors help in transferring this charge quickly, which can lead to noticeable effects like a shock. Why do we get a shock? A static shock occurs when the built-up electrical charge is suddenly discharged. This can happen when you touch a conductive object, like a metal doorknob, after walking on a carpet. The charge rapidly flows from your body to the object, resulting in a brief but noticeable shock. The sensation is due to the rapid movement of electrons through the air and into your body. Factors influencing static shocks. Several factors influence the intensity of a static shock. The amount of charge accumulated, the humidity level, and the materials involved play significant roles. Dry air, for example, enhances static electricity buildup because moisture in the air normally helps to dissipate charges. In contrast, high humidity can reduce the buildup of static electricity and the likelihood of a shock. Common situations for static electricity. Static electricity is commonly experienced in everyday situations. For instance, when you remove a sweater and hear crackling noises, or when a static charge causes your hair to stand up after removing a hat. These situations occur because the friction between your clothing or hair and other materials transfers electrons, leading to a charge imbalance. Preventing and managing static electricity. There are several ways to manage and reduce static electricity. Increasing humidity in your environment can help, as moisture in the air can dissipate charges more effectively. Additionally, using anti-static sprays, wearing natural fibers, and grounding yourself by touching a conductive object before handling sensitive electronics can help prevent static shocks. The role of static electricity in technology. Static electricity is not always undesirable. In technology, static electricity is harnessed in various applications. For example, in photocopiers and laser printers, static charges are used to transfer toner to paper. Static electricity is also used in air purifiers to remove dust and other particles from the air. Safety considerations. While static electricity is usually harmless, it can pose risks in certain situations. For example, in environments with flammable materials or chemicals, static sparks can ignite vapors and cause explosions. Therefore, understanding how to manage static electricity is important for safety in various industries. Conclusion. Static electricity is a fascinating and common phenomenon resulting from an imbalance of electric charges. We experience static shocks when these charges are suddenly discharged, often in everyday situations. Understanding the science behind static electricity and how to manage it helps in both avoiding annoying shocks and utilizing its beneficial applications in technology.